I think you're muted.
Good evening, Delta Platoon, and thank you for whoever pointed out that I was muted. So tonight we're going to be talking about dependency injection and variable scopes in Python and args and keyword arguments. So variable scopes, definitely important to know, and you won't necessarily have to implement it, but understanding how it works will help you troubleshoot your code a lot more effectively and write it, because that's something that can tend to bite you in the backside if you're not aware of the scope of your variables. And then args and keyword arguments, important, and you'll not expected to use them, but you'll see them as we go into things like Django, which is a Python-based web framework. But first thing we're going to talk about is dependency injection. So there's a few which you'll hear called rules for programming. I think of them as I think it's better to think of them as best practices. Can someone tell me what some of those are? It's a hint. There's a few on this. I'm sorry, what was that, Liz?
Code readability.
Yeah, code is written to be read. That is one that's not on here that I definitely subscribe to. Yep. A couple others are don't repeat yourself. So that means don't write in the same function over and over again. Functions should do one thing and do it well. So don't write 50-line functions that try to do everything, pack everything, but just catch a sink. Instead, try and break those down into manageable pieces where one function does one thing. And that, first of all, makes it easier to refactor your code, like to go in and change that one function. And it also makes it easier to prove the correctness of that one function through testing. And then the other one here is write pure functions. Who knows what a pure function is?
I'll always have the same output with the same input, and it'll always return the same thing every single time you put it in.
Exactly. So it's a function that, given inputs, always produces the same outputs, no side effects. So side effects, are like printing to the screen or those kind of things. So write pure functions. I like the KISS principle, which is the keep it simple, and that kind of factors into the function should do one thing and do it well, and the code is written to be read. But if a simple solution works and meets your performance requirements, that is to be preferred. So make it work and then make it fast is another way, like a corollary to that you'll hear a lot. And then the one we're going to talk about with the dependency injection is, we should decouple components or loosely couple components. So the kind of principle here is coupling and cohesion. So coupling is how tightly things are bound together, and cohesion is how well, I guess, things work together. So when we say high coupling, we're talking like if you're building something and you're welding parts together, like the welding makes them tightly coupled or highly coupled. Tightly coupled, probably the better way to say it. Or if you super glue something to something else, that's tightly coupled. I mean, and if you just do and then for high cohesion, it's like screwing things together. Like they're fit together well, but you can easily unscrew them and disassemble and put them apart in a different way. So in code, what does that mean? So we'll start with this simple example. So let's say, so the print method makes a lot, does a lot under the hood to print anything that can be represented as a string, right? But if that wasn't the case, like if we had to have a print method for each data type, so print string, print in, like if we just couldn't pass them into a generic print method. So this would be an example of like a highly coupled system. So that's kind of simplistic, but in code, it looks like this. So let's say we have this function, so make an API call to write to file. So we've got imported these fictitious libraries, HTTP request, file writer, and then we have a result, which is a HTTP request.get URL, and data, which is the result.toString, and then file object.filewriter.write data, file object.close. So the reason that this is tightly coupled is we are dependent on this HTTP request class or package or whatever it is. And we are dependent on this file writer .write. So if we want to change something like the manner in which an HTTP request is made, that's all dependent on this one package, and we have to change it everywhere it occurs. Or let's say we want to turn a file writer into a database writer for the output of the HTTP request. We'd have to write another function to do that because this function is tightly coupled to this HTTP request and this file writer. So to change that, we could basically make those dependencies, the HTTP request and the file writer, arguments to the function, which is called dependency injection. So if we just pass in, we're still passing in the URL to our make API call write to file, but we're also passing in some sort of request object and some sort of IO object. And all we need to know about those is that for the request object, it has a get function that takes a URL. And then for the write IO object, all we got to know is that it has a write function that takes in some data. If we want to change those outside of our program, like this request.get could be anything. And this io.write, we could change what IO does. Like I said before, it could be a file, it could be a database, it could be a spreadsheet, it could be printing to the console, writing to logs, it could be any number of different things based on what this IO is that we pass in. So this would be an example of tight coupling, and this is more loosely coupled because we pass in the dependencies as arguments. So let's look at this in code. So let's say, and this is all fictitious, and this is an example I pulled off the internet. I forgot what website. So this is with dependency. So let's say we have this API client, and it has a constructor, takes in no arguments, and that constructor calls get environment from the operating system, which is basically going to look in the config for a key named API key and set its whatever value is associated with that key, save it in the instance of the class's API key, and the same thing for timeout, except it's going to convert it to an int. So these are both dependencies for the API client. Like if something changes with where the API key is or how you want to store the API key or the timeout, like if they're not set as environment variables, like if they're in some other config file, or you want to change them for testing, like you're going to have to patch them. So this is tightly coupled to these variables stored in your environment. And then you have a class service, which is API client is equal to an instance of API client. So now your service class is reliant on your API client class as a dependency, and then your main function is reliant on creating a service of type service. Sorry, my daughter decided to come visit me. So your service is relying on type service. So this, like, basically main is dependent on service, service is dependent on API client. They're all tightly coupled. So If we want to reduce the coupling and make it more loose, we can do that by, so basically our main is now going to get our config. So it's going to get an API key from the environment variables and get the timeout variable from the environment variables, and it's going to create an API client from those, and it's going to create a service from that API client. So now the dependencies are injected. So main takes in a service as an argument. Service takes in an API client as an argument, like so, and then API client takes in its two config variables as arguments. So now you just know that the key is a string. You don't need to know that you're getting it from the operating system, what it's called in the operating system, or any of those things. And the same thing with timeout. And this is going to benefit you in larger programs where you have, configurations or environment variables that you're using all over the place. What you'll see is like a central configuration module that does something similar to this and says, hey, go get these values from the configuration for this project. And then you can use them all throughout the project, and each individual module in the project doesn't have to know anything about them. And then, so let's say your project has a test environment and a production environment that have different settings and different things you could do to them. Like you can configure it so these variables are different in your test environment and your production environment. Like loosely coupling enables a lot of flexibility, especially in the specific case of configuration. So we're going to look at another example, but what questions do you all have about this example? Okay, so let's look at a less abstract example. So back in the Delta Platoon dependency injection. So let's look at an application that uses dependency injection to basically, we're modeling getting a driver's license from the DMV. So the first class is this driver's license application. It takes in a name and a license type. It's got a string method. It's got a double check form method and a submit application method. So the submit application method takes in a local DMV, which looks like it's another class because it's got this move line method. But all we need to know is that a local DMV can move a line. We don't care about the implementation. We just care that it has a function that can move the line. So it doesn't have any fixed external dependencies. Like it's not reliant on this class local DMV. It's just reliant on something that happens to be called local DMV that can move a line. And then we have a class local DMV, which has a employee set, and then it has a function to move the line, which is self and application, which iterates through its list, its set of employees and tells you whether or not they can process a license based on their specialty. So this employee is another class, and we can tell that because it's got some a class, a variable, and a method, or at least an instance of an object. So employees have a specialty, and they have to be able to process a license. And then an application has to have a license type, which we see. So there's two dependencies here. We have the employees, and then we have the application, both injected in different ways. And we'll look at the way that employees is injected in a second. So we just need to know that application has a license type and that employee has a specialty and a process license. And then we can list the employees or we can add an employee. So this takes in an employee object or instance of a instance and then adds it to our set of employees. But all we need to know about employees is that they have specialty and they can process a license. Finally, we have a DMV employee, and each employee has a name and a specialty, and we know that they can process a license. So they take in an application, and it marks them approved, and then it prints their application. So this only has dynamic dependencies as well, and that dynamic dependency is an application. But all we need to know about application is that it has an approved by member. So this makes the initial setup a little more complex, but you can say, I mean, we just create an instance of driver's license application, create an instance of DMV employee, create an instance of local DMV, and then we add an employee, and then we can list the employees, and then we can submit an application to Chicago DMV, double check the form, and submit another application. Where it becomes a little more challenging with dependency injection is when you want to write tests. The upside to that is it allows your tests to be more standalone and robust, because you can basically create fake, like mock or factory instances of classes that you're not testing, and you don't care about the implementation. You only care about certain members of the class that you're not testing. So I think that'll be a little more clear when we look at this. So basically, we want to test our local DMV. So that's all we're testing is, sorry, where's the DMV? All we're testing is this class right here, this local DMV. So it's got a constructor, it's got a move line, it's got a list of employees, and it's got an add employee. So our setup is pretty simple. We just create an instance of local DMV, and then we want to test adding employees. So first, you want to check that there are no employees in local DMV as an initial condition for the test, not strictly necessary. And then we have this with patch DMV employee.dmv employee as fake employee. What do you all think that this does?
Creates a fake employee.
Yeah, I mean, yes. But code-wise, what this is doing is saying that basically it's saying that fake employee equals DMV employee.dmv employee. That's all it's saying. So it's taking this value, instead of instantiating a DMV employee, it's just creating an object for testing that equals DMV employee.dmv employee. And we can assign other values to it, like we can assign a name and a specialty, but that's all that it's got. This is not an instance of DMV employee. It's a fake object equal to DMV employee.dmv employee with a name and a specialty. So we haven't instantiated DMV employee, so we won't be able to detect any issues in DMV employee, which is fine because we're just testing local DMV. So we can add our fake employee to the local DMV, and then we can assert that it was added correctly, which is what we want to test. We don't want to test the DMV employee class. We want to test the ability of the local DMV to add employees and nothing else. So this makes the test stand alone. So if you make changes to DMV employee, like under the hood, that could affect this test, they're not going to matter because we just have this fake employee, which we're using as a stand-in for testing for an actual instance of DMV employee. And it's the same thing here. We want to test move the line, and moving the line requires an employee and it requires an application. Well, we don't want to create an employee or an application. We just want to create the stuff we need to test the ability of local DMV to move the line, right? This is what we want to test. We don't want to test that an employee can be created correctly. We don't want to test that an application can be created correctly. So to do that, we create a fake DMV employee, and we give them a name and a specialty, and then we add them to the DMV, and then we create a fake application, and then we give it a license type, and then we attempt to move the line, and then this assert called, all it's saying is, hey, was this function in the employee, was it called? Did it attempt to call it with our fake package, which is of this type right here? Oh yeah, so that's another important part. Like the implementation won't be there, but this patch will still see this as, so this is importing this into this fake app. So it'll still see this as the right type. It's just it's a fake version of it. So we can check that this process license in an application is called. Yeah, so the DMV employee gets their license, process license called, which is the final step in the move line. Yeah, move line processes the license. So we check, was it called? It'll keep a record of it being called, and if it was, this test will pass. So why do we use mocks in unit tests? So you should use them sparingly. The primary, I would say the main reason you should use them is if you're testing external APIs. So mocking like the return of an API, and we'll get to these later on, basically a call to another web server or something else on the web. So mocking that keeps you from calling the API. So you're not going to have, 10,000 pings on somebody's website just because you're running your unit tests over and over. And it'll only test what you want to test. So in this case, we just want to test the local DMV. And it'll separate the dependencies from the functionality you're trying to test. So we don't want to test the employee DMV employee or the driver's license application class. We just want to test the local DMV. So this is dependency injection is how you reduce coupling in your programs. It's a useful skill to have. I mean, as it allows your code to be more configurable, like loose coupling allows you to move pieces around without affecting other pieces. So it starts to come in handy the larger your projects or your repos get. So before we move on to variables, what questions do you all have about dependency injection?
Yeah, just not quite sure. I think once I start playing around with it, I'll be able to understand it a little bit more.
Yeah, this is one, like, I mean, just keep it in the back of your head and revisit it as you move along your programming journey. That's kind of what all the best practices are for. Like, don't repeat yourself, and functions should do one thing and functions should be pure. Like, the more you learn, the more you learn when you can break those rules and how to use those rules effectively when you are going to use them. Okay, so let's open up the code from there. So now we're going to talk about Python variable types and variable scope. Okay, so say I have this variable and I want to print, and then I also have define print. So what's if I execute this program, what's the output going to be?
Nothing.
Why is that?
Well, because you're just calling the function. You're not printing it.
Well, the function prints it though, line 5. So we got 2 print statements. So what are going to be the
Right, the
results?
first one.
Can you explain?
Yeah,
more
I mean,
what
I've
you're
just, yeah, so like when I print a function, you do print and then you call the function, and then it prints. So, and I don't know that I've ever, I mean, maybe I'm totally wrong. I don't know that I've ever done it like that, where you have a function and then you print and then you don't have to do print and then function name and then the argument and it'll still print.
Well, the function
That makes
itself is
sense.
this. Yeah, it does.
Right.
So I see what you're saying. So
Yeah, I guess because
so I got a function here to print favorite donut, and it takes in an argument called my favorite donut, and then it prints it. So the function call itself takes in something and prints it, which happens to be the same something here. So what's this going to print? Is it going to print glazed, chocolate, chocolate, like
It's glazed.
just glazed chocolate?
Glazed chocolate.
I think it'll do glazed
Chocolate.
chocolate. Yeah.
Glazed.
Chocolate.
Yeah.
Glazed
So-
chocolate.
All right, let's see. So glazed chocolate. So why does it do that? Because of the scope of these variables. So my favorite donut is defined here, and it's a local variable, but its scope is everything basically in this script. And then I also have a variable called my favorite donut, which overrides the scope of my favorite donut here. So whatever I pass in for my favorite donut is going to be the value that's used for all of this function. So if I were to change this to my donut, and then I were to print, let's say I want to do f string. Sorry, I always get my f strings confused with Scala because the syntax is slightly different. So now we should be able to print my favorite donut in here because nothing inside this function is basically taking precedence. So the way that the scoping here works is first, the Python interpreter is going to look for variable names inside the function. And if it doesn't find anything inside the function, it'll go to the next outer scope. And then the next outer scope. So it'll look for local variables, and then it'll look for variables inside the class or whatever, and then it'll look for global variables. So basically it goes inner to outer. So in the old example, the inner my favorite donut overrode the outer my favorite donut. But in this case, we've changed the name of donut. So this should print So it takes in my donut, which we've written as chocolate, and my favorite donut, which is glazed. So it should print glazed up here, and then glazed colon my donut, and sorry, chocolate colon my donut, and glazed colon my favorite donut. Which you can see that it does. So that's local variable scoping. So first it looks in the function, and then it looks in the whole program. And then another, I guess, convention is like global variable names. So if we had something in, and this is by convention, they're all uppercase. If they're constant, which global variables should be constant. So and then if we had some class, okay, so there's a few things going on here. First, we have this global constant variable, and then we have a class variable, my favorite donut, which should be available to any instance of the class. And then we have, well, let's just do it. And we can have an instance variable as well. So we have a couple of things here. We have this class variable, my favorite donut. And then we have an instance variable, which is assigned for each instantiation of the class and only exists in the instantiation of the class, my donut. And then have a global variable. So this right here should print chocolate, my donut, glaze, my donut. And then if we do it again, oh geez, I'm running out of donut. Someone tell me a kind of donut. My brain shut down.
Blueberry.
Blueberry. That's good. So this should print what? Should print chocolate and glazed, and then blueberry and glazed. And then we should also have access to my all-time favorite donut, because that's global in scope. So you could see the instance variable changes each time, the class variable does not, and also the global variable does not, but the class and the global variable are available to both instances. instance variables start with self. So that's because they belong to an instance of a class. Class variables shouldn't need a prefix. Okay, what questions do you all have about variable scope?
So if you had multiple classes and one global variable, then all classes can access that one?
Correct. So this would be available to anything in this, I guess, in this Python file, and in other files if you import this file into it. Okay, so and the final topic we're going to talk about is Args and Kwargs. Basically, Args and Kwargs are special symbols used in function definitions to pass in multiple arguments. So let's say I have some function sum, and it takes n1 and n2 and return n1 plus n2. And then I want to print sum of 1134. But let's say I want n3. So now I need to add another number, so 12, and then we call our function again, and we get 57. And let's say we just want to keep adding, like we want sum to be able to take an indeterminate number of numbers and return the sum. How would we do that? Well, in order to accomplish that, there's special syntax in function definitions, and it's this Args. So this syntax right here allows you to pass in a variable length list to your function, which you can then reference inside the function the same way you would reference a list of anything else. And that allows you to take in more arguments than the number of formal arguments that you would be able to define. So you can basically have any number of extra parameters tacked on to other parameters. So in this case, let's say we have an indeterminate number of nums that we want to add. Let's make this a sum, and then we'll say, we'll say for num, sorry, we'll make this args. You can name it whatever you want. It's the star that tells you that it's an indeterminate list. But just for this, we'll say star args sum plus equals num. What don't you like? Oh, I don't need the star there. That's why. So now we can pass in any number. So we got a 57 before when we executed this. We should get a 57 again. But we have to return the value in order to get the 57. Very important. So you can see we get 57, but then we can just add numbers, right? And it'll continue to work. I don't know if that's the answer, but it looks good. But it basically, you can take in any number of numbers in addition to n1 and n2. You have to have an n1 and an n2. You can have 0 to an indeterminate number of arguments. basically this takes in a list and you can interact with it like you would interact with a list. So I can say if length of args is greater than 0, prints null. And you can see, because we have more than 2 arguments, because we check the length of this args list, we're able to tell that by checking the length of the list. So the counterpart to args is kwargs. And so when I say kwargs, I mean keyword. Think of this as keyword arguments. So basically, you provide a name to the variable as you pass it into the function, and it's a dictionary of that name and the value that you're passing in. So let's say we want to do introductions, and we take in some data, and then we want to know what the type is. So let's do a string. So we want to know what the type of the data that we're getting is overall, but then for each key value in data type items. So these look familiar because this is how we interact sometimes with dictionaries, right? So we're unpacking each of the items in our data dictionary and retrieving the key value pair. So we want to print, let's say, string key. And that's all we want to do. So let's say we want to do an introduction, and let's say so we got some other stuff in there. So what is this going to print? Who can help me out? Let's see who I haven't heard from. About one of the Nicholases or Nicks, whichever. What's this going to print?
It's just gonna print. So you got the data type on the new line up on your line 35. It'll print that you've got a class dictionary, and then you'll just print your first and last name on a new line as well.
So it's going to print the key and the value. So think of this as being packaged up in a dictionary. So our keys here are the variable names, and our values are the values of the variables. So key, value, first name is key, Joe is value, last name is key, Smith is value, address is key, 123 any street is value. So this will, so you, that you're correct, except it's going to iterate through each of the items in this data dictionary here and print the key is the value.
Yes.
So let's take a look at that. Yeah, that's, yep. So this is exactly right. And he was, and exactly right as well. And then you could, I mean, you could iterate on this any way you want.
Is that new line marker on 35? Is that what makes it them each print out on a new line, or is that just how,
Yeah, I don't
This
think
stuff
this is strictly necessary. Yeah.
is that just how Kwargs get printed out like that, or just because it's a new statement,
Yeah.
key value pair being printed out?
So, because a print statement, unless you tell it not to,
Yeah, because it's
we'll print
iterative.
we'll print a new line.
Yeah,
So each print statement will print a new line unless you could set an optional flag to tell it not to, but by default, a print statement will print a new line at the end of whatever you're printing.
okay, yeah, I think I just kind of spaced on the fact that it was looping through the items. So, thanks.
So, but you could put whatever you want as key value pairs, like the function doesn't care. And it should print the same thing, like breakfast is delicious, lunch is yummy, dinner is savory. Like this makes no assumptions about, at least this implementation, about what the key is or what the value is. And that's kind of one of the benefits of Kwargs, is that you're passing in, essentially, it's converting it to a dictionary to pass it to the function. So let's get rid of this.
Since it's a dictionary, does that mean like the keys you pass in have to be immutable?
Yeah, well, they're just variable names. So yes, they do have to be immutable. They'll be the variable names, which should be immutable to start with, but yes. Because
Okay.
the key is always going to be whatever the variable name is.
Okay, okay. Thank you.
So just to wrap it up, so decoupling, how you decouple classes, functions, methods, program objects by dependency injection, which is where you don't make the internals of your class or function responsible for other classes and their implementation. Like you want them to be able to support an arbitrary class with a function that does, that's called what you want it to be called. So, you know, instead of file writer dot write, you have IO, which is input output dot write. So any input output object. That's dependency injections, and then variable scope. It's important to recognize like what the scope of the variable is. So you have global variables, which are typically constants. So global variables defined outside the class and the general parameters of the function, capitalized if they're constant, and that's by convention only. Like if I wanted to go in and reassign this, I could. And then you have class variables, which exist for every instance of the class. And then you have instance variables, which only exist for an object of the class. So only when you've created an object of the class. And those are, and then we also looked at, you know, variable scope. So remember, it looks starting in the function or for comprehension, it's going to look inner to outer for the value of a variable. So if it's defined in a function, so if I had a my donut and a self.myDonut, it'd probably throw an error. But if it didn't, the instance is going to look for my donut that's scoped to this function before it looks in the class scope and before it looks in the global scope. And then args and kwargs. So args allow you to pass in a list of arbitrary length of argument in addition to other arguments to a function. And then keyword args allow you to pass in a dictionary of key value pairs to a function. And the big benefit to these args and kwargs is that they make functions a lot more flexible. So what questions do you have on any of the topics that we went over?
With the Kwargs, is it gonna always need the equal sign when you pass in your dictionary, or if you put like a colon, is that gonna throw an error? Versus the, we have first name equals Bob, if we put.
I think you gotta have an equal sign. Like, I don't think you'll be able to, yeah.
Okay,
It's just like, it's like named parameters to a function.
okay. I didn't know if it was looking for like a comma to separate the key value pairs or what.
No, it's just like passing parameters to a function, named
Okay.
parameters.
Cool. Thank you.
By the way, Sean, since our topic is like dependency of like variable, is there like a way to like go to like a shortcut to go to that class that it's being called?
I'm not sure I understand
Oh,
the
like to
question.
say, for example, in that server dependency py that you showed,
This what with dependencies?
like the service with dependencies.
Okay.
Like
And
for
this,
example, you have like a lot of variables, and then like instead of going through all the, for example, the code is very long. Like,
Mhm.
is there like a way like to go to that?
So like the definition of this?
Yeah.
Yes. In VS Code, you can go to definition,
Okay.
but it's not as robust in VS Code. So I can go to this definition usually, and then I can look for it. And that'll take me to the definition here. Is one way to do it. In other development environments, like so for my my day job, when I was working in Python a lot more. So Jordan's talked about NeoVim versus VS Code, right? So what do y'all know about the difference between NeoVim and VS Code?